So far we started with graphing radical equations, and then we took radicals and simplified them, and then we went a little bit further and we made actual expressions with radicals and simplified those. Now it's about time we throw some radicals in some equations to try to solve. So a radical equation consists with our variable being inside the radical, or being in the radicand, I guess you would say. And it's based off our theory of this. If a equals b, then a squared equals b squared, right? If I square both sides, right? If I do something to one side and do it to the other side, it keeps my equation balanced. Because if I look at this situation down here, the square root of x equals 4. Well, most of us can think, well, x should be 16 here, right? Because the square root of 16 is 4. Well, to get rid of this square root, we always do the inverse of what's being done, right? I want to get x by itself, so I do the inverse of what's being done. And the inverse of square rooting is squaring. So if I square both sides, what happens to our radical is it gets rid of itself, right? Anytime you do the inverse, it kind of cancels it. Because the square root of x times the square root of x is this square root of x squared, which is just x. They just cancel each other, right? The square cancel each other. And I'm left with 4 squared, which is 16. And if I plug it back in, it works, right? The square root of 16 is 4. So whenever you want to get rid of a radical in an equation, you just square it, right? You do the inverse of square rooting, which is squaring. Let's take a look at a couple examples here. Our first example, I got the square root of c minus 3, and that's being subtracted by 2, and it equals 4. So my goal is to get c by itself, and we got to treat this radical like it's a bracket, like it's parentheses. So I need to get that radical by itself. So I want to add this 2 over right away because it's on the outside. So I'm left with radical c minus 3 equals 6. Okay, get that square root by itself on one side. Okay, so to get c by itself now, I got to get rid of that square root. And we just talked, the inverse of square rooting is squaring. So I want to square that square root of c minus 3. And whatever I do to one side, I got to do to the other side. So what happens is my radical, my square root and my square cancel each other. And I'm just left with c minus 3 equals, well, 6 squared is 36. And to solve for c, oops, we add 3 to both sides. I'm jumping ahead of myself. So c equals 39. C equals 39. And I could always plug it back in and check. If I plug in 39 in my original equation, 39 minus 3 is 36, and the square root of 36 is 6, and 6 minus 2 gives me 4. So it works out. Okay, it works out. Same thing over here. Same thing over here. Goal is to get h by itself. So it's inside the radical, which means I need to get that radical by itself. Get that square root by itself. We'll treat it just like you normally do, right? Work backwards, deal with your adding and subtracting first, then you're multiplying. So my first step is to subtract the 4 over, right? Just like way back when. And you're left with 2 times the radical, h plus 1 equals 24. Okay, I still want to get that square root by itself, so I'm going to divide by 2 to get rid of that 2 out here. And I'm left with the square root of h plus 1 equals 12. And just like we talked about, the inverse of square rooting, to get rid of that square root, is squaring. And whatever I do to one side, I do to the other. So the square root and the square cancel. I'm left with h plus 1 equals 144. And we subtract 1 to give ourselves 143. 143. Okay. So just remember, get that radical by itself if the variable is underneath it. So for example, this first one, the c was underneath the radical, and the second one, the h was underneath the radical. So get the radical by itself so you can square both sides. Look at a special situation here now. So if you notice, you have variables on both sides, right? One of them's under the radical, one of them is not. By looking at this, your goal is to get the variable to one side, right, and then get it by itself. So before we can do that, I have to get rid of that square root. Have to get rid of it. Okay, so I want to get rid of everything else with the square root, which I did. There's nothing being multiplied out here, right? There's nothing being added or subtracted to it. So let's get rid of that square root. And to do that, just like we did before, we got to square both sides. But this is where it gets tricky. So if I square the left side, which means I have to square the right side of the equal sign, well, I have to square the whole side. That's the trick. So when I square this, I don't just square each term. I can't do that. I have to square the entire side. So I'm going to put this in parentheses, and I'm going to square the whole side. Okay, well, the left side's easy because the square root and the square cancel each other. I'm left with m plus 5. Well, over here I have m plus 3 squared. And like I said before, it's just not m squared plus 3 squared. That does not work. You can't do that. Okay, if I want to write this out, I can m plus 3 times m plus 3 because that's what squaring means, something times itself, and go through the entire FOIL, right? First, outsides, insides, last. But if you remember your special product, whenever you square a binomial, it's the first one squared, m squared. Leave some space, it's the second one squared. 3 squared, which is 9. And to get that middle term, I multiply the two. So 3 times m, which is 3m, and I double it for 6m. And if I went through the FOIL, I'd get the same thing. I'd get the exact same thing, right? M squared, 3m and a 3m for 6m, and then plus 9. Well, now look at this here. I have an m squared, don't I? That means I have a quadratic here. So whenever I have a variable squared or a quadratic, I always want to get my equation equal to, I think I heard some of you say it, 0. So we got to get this thing equal to 0. So let's get everything on one side. So I'm going to subtract a 5 over, subtract this m over here to the right side as well. So now the left side's gone, I got 0. We got m squared plus 5m, right, 6m minus m, and plus 4. Uh-oh. We're going back to last chapter again, are we? So a couple ways to solve for m. I can either see if it factors into a product of two binomials. I can use the quadratic formula. I can complete the square. My best advice is to check and see if it factors into two binomials, product of two binomials. And then if it doesn't, I'd probably use the quadratic formula. That's usually my best advice. So if I'm going to see if this factors, remember I look for factors of C that add up to B. So factors of 4 that add up to 5. Well, my only factors of 4 are 1 and 4 and 2 and 2. And 1 and 4 happen to add up to 5. So I know that I have m in my first term, right, because of the m squared. There's no coefficient out here, so I don't need to go through my whole grouping. And we just have plus 1 and plus 4. And like we did before, as long as one of these is 0, the whole thing's 0. So m equals negative 1, right, because I need to get that to 0, and negative 4 to get that one to 0. Okay, so it looks like I'm done. Although I have one issue here. There's something in radical equations called extraneous solutions. Okay, and what that means is it's a solution that might not be right because I have this radical here. So what I have to do is I have to check to see if both negative 1 and negative 4 work up in my original equation. So let me test it when m equals negative 1. I'm going to plug in negative 1 plus 5 equals negative 1 plus 3. Just plug in negative 1 for m. So here I got square root of 4 equals 2, and that works out. That's good. So I know this is an answer. I know negative 1 is an answer. Now I got to try when m is negative 4. So the square root of negative 4 plus 5 equals negative 4 plus 3. Well, if I notice, the square root of 1 does not equal negative 1, so that does not work. So m cannot be negative 4, which means my only answer is m equals negative 1. So anytime I solve a radical equation, I should always go back and check and see if it works, because it might not always work, especially if I have a negative inside the radical. So always go back and check. And these two both should have worked out. Like I showed the first one how it worked out, the second one also works out when you go through it. But you should always go back and check to make sure it works, okay? Because sometimes you might not use all of your solutions. Okay, there you go. Just remember the inverse of square rooting is squaring. Whatever you do to one side, do to both sides, okay? And just remember all your past knowledge. You're going to use a lot of it. Good luck. Deuces.